All right.
Hello everyone, good afternoon. Welcome to UTA Planetarium's another live star stream. My name is Levent Gurdemir, UTA Planetarium Director and Astronomer. And here in the studio, Jim Bader, the Program Coordinator with me. And today we'll talk about an interesting news with you. So Jim lined up great news, great subjects for
Definitely,
us.
definitely.
And before everything, I would like to just give a quick update from night sky. So I would like to say hello to Kurt and Janet.
Yeah,
for
thank you
coming
guys. Always here. We're so grateful. So glad to have both of you guys here. Yeah, every time. Anyway, sky,
All right.
that's what you want to do, right? You want to see the sky?
Yes, please.
Okay, I
Take
gotta
me to
show that
the
to-
night sky. Take me to my backyard. So, as you noticed, sunsets are getting later and later. And how long this is going to take? Until the summer solstice, right? In the later June, we'll have a summer solstice. This is going to be the longest day of the year and the shortest night of the year. When we take a look at the early evening sky right after sunset, you will notice one thing. You will notice two planets in the western horizon. Let's take a look at the west direction and find the constellation Gemini. So,
All right, we're headed west.
all right, yeah, let's head west. And in the west direction, you cannot miss. There are twin stars. You will see like two almost identical
Well, then
stars.
I have to interrupt you because of something that you showed this earlier in a program, so not to spoil it for everybody else, but what's over your left shoulder, I was very confident was the handle of the Big Dipper, and its placement in the sky was extremely confusing. Am I crazy to say that looks like the Big Dipper? If you scoot over, let me get out of the way, but if you scoot over, do you see that, what I'm talking about?
Yes. Yes, but this is not Big Dipper, right? Big Dipper is in the north direction.
Definitely not.
So, yeah, this is not Big Dipper. But when you look at the west direction, you should not miss these two identical stars. Those are Pollux and Castor, the bright stars of Gemini constellation. Gemini, also known as twins. And here, let's go a little later in the sky because I would like to see the horizon a little bit more, or the bottom of the constellation.
Oh.
And there are like the two bright stars in the constellation. There are also two bright objects in the same constellation too, that they are called either visitors or wanderers. So wanderer means planet. There are two planets up in the Gemini tonight. So one of them is over here, Mars. We'll take a look at Mars, and over here, very low in the horizon, there's a second planet. So I'm not going to tell the name of the second planet, but let's talk about this one. So let's zoom into that.
You could give them a hint, though. I mean, it's the brightest thing in the sky other than the moon. We'll just leave it at that. In the night sky, I should clarify, just so we don't have anybody who's too annoyed by that. Anyway, let's zoom in Mars. Here we go.
Oh, I see Lamia too. Great. So welcome. Here is Mars. Mars is dry red planet. As we talked before many times, we have rovers exploring Mars, right? And there's also drone flying on the surface. So this is dry desert planet, and it's a red planet. And did you guess the other one? Anybody was able to guess?
We didn't see in the chat yet. I don't know. We could just.
Let's just zoom it. I mean,
Okay,
this planet
all right.
tends to show nothing about its planet. It is just showing thick clouds.
Can they guess now? It's I almost said its name. To me, it's the most boring planet to view in a telescope. Not in the night sky, obviously. It's extremely bright, but it's not very fun to look at in a telescope. I mean, it's just a smudge. Maybe I wasn't looking at it the right way. I don't know.
Well, when I looked at this planet with a telescope, I always see like a very bright. It is pretty much like looking at a mirror. It is very, very bright light source. So it is not even possible to see the clouds like this. So
We have some guesses.
we have a lot of, I think, wild guesses. Sirius, Jupiter, no, none of them.
Those are
But-
good guesses, though, right?
Oh, those are
Yeah.
certainly good guesses.
They're like
yes.
they're the next two brightest things down the list.
Well, about this planet, let me give you a hint. It is the hottest planet. Yes, Lamia, great, great guess. Venus. It is hard to guess because it may look like Venus, but you can tell that there's a distinct difference between like Jupiter, Saturn site and the Venus site. Venus is first, always low in the horizon. Second, it is extremely bright, and usually it is mistaken by UFO when the Venus appears in the low in the horizon. This
Whoa,
is the-
whoa, whoa! UFOs. You're not going to join that trope of people on the TV and the internet. UFO, UAP. What does that mean? We need an explanation.
I don't have the explanation.
That's the point, right? It's
Well-
unidentified.
Yeah, I mean unidentified objects. So usually when the Venus is low in the horizon, we get the most calls to the planetarium saying that I
Emails.
saw an object on the horizon. It was so bright, it was moving, it was making sparkly and colorful lights.
I even got a video
Yeah,
like 2 years ago. Somebody brought a video into the planetarium and
Uh-huh.
asked.
And on the web, I realized we started seeing these UFO stories again. There are a lot of posts made, like there were mysterious lights in the sky, mysterious object in the sky, and I think that the popularity of UFO sightings are coming back.
It's back.
Who
Well,
knows?
it's what's so obnoxious about this is that when you have a normal person, or let's just say a scientist, says, "Hey, I don't know what this thing is," other scientists say, "Oh, yeah, that's okay. We don't know most things," but it only takes one person to put a little bit of a spin on it, and let's be honest, it's way more fun to imagine that there's aliens coming to visit us. But I want to hear, what do you think the chances are that we have actual extraterrestrials coming to visit us?
I think we need to just do a whole program about this because we
Maybe we'll
need
do that.
to go into the cosmology a little bit.
I'll
the,
make a
the
poll and
universe,
see if they want
time
that.
a little bit and explain it. But I have been looking at the night sky even with professional telescopes, with amateur telescopes for decades, and I have seen a lot of interesting things, but I have not seen any unexplainable things. And I think today we have more likely to see more interesting things in the sky actually, because there are like more interesting satellites. There's a International Space Station. There are the Starlink satellites that they are making a very, very bright sightings. So in the sky it has full of interesting things besides constellations and planets. So let's go with the news. We don't want to spend the entire 30 minutes with the constellations and stars in the night sky. And I think we have great news we would like to talk about. And one of the
Definitely.
news is about this planet, right?
Yeah, we do have news on that. I did post the poll. I just want to say, you guys, we have a poll. Please vote whether we should do a whole program on extraterrestrials. Or I said ET, but really I meant UFOs, UAPs, whatever you want to call them, Bigfoot, Sasquatch.
Can I
Well,
add some water on the surface of Mars?
Yeah, do it. That's what.
That's a little trick. This is how Mars would look like with water on the surface. So I added about some water, and as you see, only one hemisphere fills with water on Mars. So Jimmy's highlighting me a question: quadrillions of cubic miles of unexplored space. I can't say there is zero chance or other intelligent life. And there is also another memory of a astronomy professor told years ago. So one of his student asks like, do you think, hey professor, do you think there are some life exist in anywhere else in the universe? And his answer is, well, if not, that would be such a waste of space.
This is where you hear that. I don't have a drum set in front of me, but whatever.
Whole show on
I don't know.
UFOs. How fun.
I mean, I think is there a chance that there's life out there? Yeah. But I think the real question that people are struggling with, at least in social media and the news, is do they have the technology or the means to come visit us? And if they do, are they?
Yeah, well, first we need to define life. So when we say
what we probably should do, Levin, is
there life
save
out
this
there?
good stuff.
Is there? Yeah, I mean, is there life out there? Immediately we think about humans. But the first thing we are trying to explore on the surface of Mars, we are hoping to find bacteria. Like mold, for example. Mold is a form of life. Mold may exist anywhere, maybe sometimes in homes or outdoors, but mold is just a big amount of bacteria. So our goal is find a bacteria or maybe a small plant or maybe an animal, maybe humans like us. Maybe there may be even more intelligent life than us. So there's a wide spectrum, and not necessarily all form of life requires water, air to breathe, sunlight to get energy, etc. So for that reason, there's a broad range, broad definition of life. So if there's life, can they come over here? Well, we cannot go there, that we know, but they may come over here possibly. But we also need to think about the time we are living in. So because we are always thinking like somebody is living just up there now, or they lived in the past, or they are going to live in the future. So our human life, or even the life we exist on our planet, is a very small time window for the universe time. So in the universal time, the civilizations pop up, exist, develop, and then extinct. So life may have existed somewhere 100 million years ago, then we had no idea about it, and life may exist 100 million years from now somewhere else, and we will not know it because we won't be here. So I mean, we need to just add the other dimension, that is time, for to answer this question.
Let me just dropped a very important comment in there. Not a question so much, but 100% agree with that.
Mm-hmm. I think that we may find life just in case we survive enough to get the technology. Yes, technology is certainly a problem, but also besides technology, I don't think we know enough physics to go at a very distant place.
We're going to talk
quickly
about that later, Levin. Don't get too far into it.
All right. So I'm not getting ahead.
News time?
Let's go with the news.
Okay, news time. Here we go.
We had a lot, enough of UFO talk.
Well, maybe a little bit more later on. Anyway, let's get to news number one. Volcanism on Mars,
No.
Levin. There's no volcanoes on?
No.
But I've definitely heard you say that the largest volcano in the solar system.
Where's my astronomy book? It says there is no volcanism on Mars.
We should clear no volcanism on Mars.
Mm-hmm.
True, I accept that. But isn't the largest volcano in the solar system on Mars?
Yes, Olympus Mons.
What I don't understand. What doesn't make any sense. No volcanism, largest volcano.
Well, we thought that Mars was volcanically not active for a long time. So yes, the biggest volcano is located on the surface of Mars, but we were thinking that planet just cooled down in the interior, and the magnetic field also supports that. It cooled down in the interior, and because it's a smaller planet, it is likely that there is not enough the magnetic activity and interior lava activity to keep the planets hot enough. Also, Mars's moons are very small. So one purpose of the moon, I think we talked during one of the stream, when a moon is orbiting around a planet gravitationally, it actually stirs the interior of planet, stirs the magma. So that keeps the interior of the planet hot. But in the Mars case, Phobos and Deimos are very small pieces of rock, so they are not big enough to stir the interior and keep the interior of the planet warm. So we thought that Mars was just cool and not showing any volcanic activity, but apparently we were wrong. And like like tectonic plate activity like this, a rip on the surface, and
Yeah.
there were some other evidence too that Mars may be volcanically active inside.
Yeah, we got some new research that originally we thought that it was like 3 million years ago, right? That Mars was seeing any volcanic activity, which, let's be honest, that's still really soon in the whole 4 billion year history of Mars, but they moved the timeline up to 50,000 years ago. So with volcanoes on Earth, that's energy. When there's energy, we've got heat sources, things could change. And on Earth, that typically means life. What kind of impact do you think that would have in terms of what we'd expect to see with life? Should we have landed, instead of in Jezero Crater with Perseverance, should we have landed where this was found? It's called Elysium Planitia. I can't. I'll type it in the chat. But Elysium Planitia.
Yeah, Planitia, I think the right word. It is the second largest volcanic region. It may be interesting locations, and that's why we are exploring Mars. That's why we are not giving up on Mars to say, well, we looked into that and no signs of life. We are still, because we do not know a lot of things about the interior of Mars. We found, the satellites found the evidence for underground water on the underground.
I do remember that.
Beneath the surface. So that means, and with some the energy production, if like the volcanic activity exists and they produce energy and supplies it to the water. So I think we are putting the necessary building blocks to say Mars may support life inside
I
rather
think this is
than
just like
outside.
More evidence that we should feel a little more comfortable crossing our fingers that we'll find something, or maybe not crossing our fingers, but certainly interesting. And we know this about Elysium Planitia because we have a lander there. The InSight lander is actually there, and its whole job is to look for volcanic activity and interior activity, maybe I should say, so not necessarily volcanic. It's interesting, though. I thought this article was super cool.
Yep, certainly. There is a lot more to explore for Mars. I think there is going to be more and more missions to Mars, and it is certainly, I think, that the best interest. And after Mars, it will be, I think we'll talk a lot about Enceladus when we have the projects funded. So Enceladus is the one of the large moons around Saturn.
I'm really excited about those.
It is certainly a second place to look for the signs of life in the solar system. So don't go far. There may be still life in the solar system.
We can only hope. Anyway.
All right, so let's move on.
Yeah. Okay. So next thing that I want to bring up, it's astronomy related, I think, but I think what to me made it stand out so much is that there's a part of it that's kind of close to us. So I want to talk about the new NASA budget. I don't know if you saw it, but it was quite interesting. So NASA's supposed to get a budget increase, which is a positive thing, right?
Sort of.
Depends how they use it.
Exactly.
But I noticed a little caveat to that, which was that they were also saying they wanted to cancel Sophia, and that's like close to us here at UTA, right?
This aircraft, right?
I should have gone upstairs and got it. I'm so sad. I have a picture, but that's it.
Yeah. Well, every time project is just canceled because of some budget issues, and also if that's a program that invested a lot, that breaks my heart because like I mean for Sophia, if you don't know the story, NASA scientists were, or scientists around the world were needing a good infrared telescope. So there is an infrared telescope in space called Spitzer, but
I
mean,
think it's no longer working. Am I wrong?
yeah, no longer working. It failed at one point. It served for a great time, but it was a small telescope anyways. And infrared telescopes needs to be like far away from Earth, so they put it on orbit that they actually drift away from the Earth every day, but still conduct the observations. But anyway, I mean, the putting a telescope in space is costly, that I understand. So some people came up with an idea. They said, well, the problem that we cannot conduct the do the observation, the infrared observation from the surface of Earth, because the air absorbs the infrared light significantly, so we do not get any signal, or we get very weak signal. Telescope needs to be in space. Reasonable. But some engineers and scientists came together and said, maybe we can just find an alternative solution. What if we just put the telescope on an aircraft, and that aircraft flies high, and the significant part of the air is below the airplane, and very thin layer of air is above the airplane? Would that work? And yeah, why not?
This idea seems so far-fetched, though. I mean, it's worked clearly for years now, but the idea of taking a very, I mean, telescopes are zoomed in so far that even the tiniest little vibration is devastating. I mean, even with our telescope on top of the parking garage, you get vibrations from cars at the bottom.
Yeah.
And airplanes are crazy.
Well, I've been to the facility who actually built this aircraft, not the aircraft itself, but the telescope door. So they purchased a 747 used 747 air jet, and they, for the first time, they cut a hole into the fuselage, put a sliding door, overhead door, and they also put a telescope inside. And the telescope has its own way to just maneuver, and if you're inside the aircraft, this aircraft is flying uncomfortably tilted most of the time. So anyway, but that was a good idea because they can conduct the infrared observations, and also that telescope returns back to Earth after it completes the observation run. That means you can maintain the telescope, fix anything that is wrong, etc. So that was a great idea. They implemented it and they used it for years. We even had done 3 different planetarium programs and more public outreach programs for the Sophia. We had a great partnership. However, when it comes to the point that they say, well, it costs $85 million to operate and we cannot justify the cost, that makes me a little angry, because
it's sad, but
I would like to say, what do you mean you cannot justify the cost? Because this is not a surprising cost. It was known at the beginning how much the aircraft costs, how much it takes it to maintain it, how much it takes to run the telescope, maintain the telescope, store the aircraft, change the tires on the aircraft, fuel the aircraft.
It is worth noting, though, that they did NASA propose canceling it twice before. This isn't the first time. And in 2015, Congress at the last minute said, we're going to give you the extra money that you need. Justifiable or not, like you mentioned, they knew what they were getting when they went into this.
It was also canceled, if I remember correctly, like 3 times before they actually made the aircraft.
I didn't know this.
Yeah, I mean, they just funded the project and canceled it, and they just funded again and they canceled it. So that was pretty much like James Webb. I mean, It
speaking
took
of
many
James Webb,
years.
that's part of why they mentioned they think it's okay to cancel it, is that James Webb is going to do a lot of infrared work.
Uh-huh. And as you
And
can see, the aircraft carries a United States flag and German flag, because the whole aircraft comes from United States, but the Germans built the telescope and some of the controls with the telescope. So that's a big partnership project.
definitely, it lands both here and in Germany, if I'm not mistaken.
Mhm.
I think it's got a home in both places. I don't know. They
Yeah.
said they don't have any current major improvements for Sophia, so the instrument's probably not going to improve dramatically. And we're also
Yeah.
going to be putting James Webb Space Telescope up there, and
I mean, astronomers are craving for telescope, and I agree with Kurt. They already built it. The hard part is past, so they just have to maintain it.
yeah,
Yeah. And what happens when these projects go unfunded and cancelled? Not only a lot of scientists are losing their job, but also, I mean, you have to just scrape a, a very nice aircraft and very nice telescope. A lot of hard work, labor, and engineering is just thrown into the garbage.
yeah. What do they do with that? I mean, the telescope. It's designed. I mean, what do you do with it? Do they just put it in a museum?
Well, probably, but it's a 2.5-meter great, telescope. It can be used for, I don't know.
Probably, yeah.
I would keep it if it was me. It's not very expensive to keep it, rather than just building it and engineering it and running it and
Yeah.
then tossing it.
Well, along with the other NASA budget, there's a huge improvements and increases to a whole bunch of other things, specifically related to climate change and other Earth programs. But they also want to put science first. At least that's the claim of the current administration, and that means sending money to programs to get us back to the moon and back to Mars. So we'll see. End of the year, right? I think it's like November 1st. We're expecting the launch of our space launch system and Artemis missions. I guess we should
Yep.
say. But yeah, we'll see. We'll
All
see.
right, what do you have next on the
Okay,
list?
next on the list we have the next one's a little bit exciting. I'm a little nervous actually to bring this one up. I feel like it could get some pushback.
Patricia asks, can viruses live on Mars? Well, the viruses are smaller form than bacteria. I'm not a expert on the microbiology, but I would say yes, they can live wherever bacteria can live.
Yeah. But that's that's the kind of life we expect to see first, right? Is that
Yes,
kind of life?
yes, yes.
Okay. Next news article. This one. Hopefully, we don't get a lot of pushback on this, but I saw the articles.
Where did you take me?
That's the question. We're just talking about life and how it could travel, and if you're going to travel, you're going to have life. You got to do it like Star Trek. And so our next news article, is warp drives.
Warp drives?
Is it possible, Levent? I'm just going to ask you outright.
I don't think so. It sounds like always the fiction. It is theoretically possible, and scientists argue that all the time. But that's the matter of general relativity of Einstein, whether warp drive can be or would be possible or not.
All right, so I think for most people, just a quick backstory, warp drive is a silly idea, an idea that you could warp space and time and just kind of skip through areas, right? So you're not breaking the laws of physics, you're not going faster than the speed of light, you're just moving through space in a different way. And we see it in science fiction, like Star Trek, we see it in Star Wars, these other types of things. But a Mexican physicist, this is a very famous thing, I think it was like in the early 90s or the late 80s or something, came up with this thing that he called, I guess was named after him, the Alcubierre drive, which was an idea to create a bubble around you in space, and you could just kind of warp through it and move much faster than would be I want to say classically, but light speed and classically doesn't always work out together. But you'd move faster than would be classically accepted. This would be a warp. But most people said that's impossible because I think in order to do it, you need negative mass and negative energy. And that doesn't always work out super well, right? At least not in actual practice, maybe theoretically. But
Well, we also have the concept of wormholes, the theoretical tunnels that the two black holes in the universe through the window they rip in the universe, they just form a tunnel from the back end. So you're getting inside of one black hole, and immediately you are finding yourself at the door of the other black holes, and you are coming out, and you are immediately in different part of the universe. So you traveled in no time. So
what do they call Einstein-Rosen bridge?
Yes.
Or something like that?
Yes.
I can't remember the exact name.
Yes. Well, to be able to say whether this is possible or not, I think we will need to explore or know more about physics,
Yeah.
especially the general relativity. And then if you're just going close to the speed of light, we will need to know more about special relativity, which both Einstein had great ideas about it.
I don't know. Anyway, so the news to this isn't something that happened in the 90s or the 80s, but that there was 2 papers done separately, not the same. And one of them said that it would be possible, and you didn't need the negative energy to do it. And then somebody else independently, so these 2 researchers, the first paper is done by Alexei Bobrick and Gianni Martir, I'm going to say that last name wrong, Martire. And then another paper by someone named Eric Lentz did this whole thing geometrically and found you also don't need it. So it just took, these 2 people solved one part of the problem without the need for this negative energy, which if it doesn't make sense to you guys, it doesn't make sense to me, that's for sure.
Well, I'm not a general relativity expert, but the negative energy is something that I'm having trouble to imagine because negative energy requires negative mass. If E equals mc squared, then to make the energy negative, you need negative mass. And how mass can be negative?
Yeah.
Can you owe mass to the universe? If the mass is negative, is the gravity will be negative too?
I don't know.
Force?
This is where we bring in somebody else.
Yeah. Instead of pulling the objects onto the object, are they is that going to just push away? I don't know. I mean, we never seen.
Who do we bring in to interview about this? Dr. Lopez?
Dr. Ramon Lopez is a great candidate.
Well, we'll have to bring him back.
Dr. Zisfa Musilak too.
Oh, yeah.
We have 2 great professors of physics whose
we got to bring Musilak. We already brought Lopez. It has to be Musilak.
Okay.
All
I'll
right,
call him after the stream.
Okay. Anyway, yeah. A little bit of a sidetrack there, folks. Kurt says, if you believe data can be sent through a wormhole, then people can theoretically be transmitted elsewhere. That also sounds very Star Trek to me.
Yes, if we can send data, well, data needs a carrier. All data the data is either transmitted with the signals that we know as like Wi-Fi radio signals, or they move on the copper pipe, copper cables, right? So they require a medium. So we cannot just send data in space. We can also send data with light too, because we have optical wires. Light is another form, and maybe we can transmit data with lights. But first we need to know that whether light can pass through a wormhole or not. If light can pass through a wormhole, yeah, maybe we can just use wormholes to send. We can just use them as like an optical wire.
I don't know. It's certainly interesting. Richard said something earlier that was important to bring up. They say nothing exceeds the speed of light, yet also claim that black holes excrete over a warp. I don't fully understand the last part of that, but
yes,
I think the idea that that a black hole has so much mass that it can stop light In a way, I mean, black holes break a lot of the rules. That's part
So
of the problem, right?
the surface of black holes is actually the boundary of our universe. And we know that time slows down as we approach to a black hole, and time stops at the surface of a black hole. And everything, including light, stops at the boundary of black hole. So that's
Yep.
required by general relativity, required by general relativity's equations. And one funny thing is because the edge of the black hole or surface of the black hole is the edge of the universe, which we cannot just trespass. At the boundary, the equations break down because then the last equation is divided by 0. So what happens if you divide something by 0? Try with your pocket calculator, it will give error. Try with computer, it will say, no, this is not allowed. So the division by 0 is not a good thing. That means the equation actually doesn't work on the surface of black holes. How about inside? Certainly, we need different set of equations. We need to develop a new physics, like the physics we use on our daily life that stops a car, stops a train, or make an airplane fly. That physics is called classical physics. So classical physics is the physics for our world. There is a different type of physics in the mini world. If we are working on like electrons and protons and the reactions, nuclear reactions and so on, we are working on the quantum world. So we need quantum physics, which is not a complete physics yet. We can only solve it for only one particular atom in the whole universe, and that's hydrogen. After hydrogen, we haven't developed the necessary physics and equation yet to understand that, so that's quantum physics. If we are dealing with the things like that exceed speed of light or near black holes, then we are going into general relativity, which is a whole new different physics. If we are working with GPS satellite signals, we are working with the special relativity physics, which is a whole different world. But we have not yet a physics for inside of a black hole.
Yeah, yeah. Kurt points out something that I think is important. If you can solve negative mass, you'll surpass all other weight loss programs available. I'm not sure that pans out perfectly.
Going
but I
to the moon is
understand your
easier.
sentiment.
It drops the 5 out of 6 pounds right away. If you would like to feel like 6 times less weight, go to the moon. We have great programs. We send people to the moon to feel them, like just make them feel better.
And last, Kurt continues with his transmitting data through space, and maybe there's something to a black hole, but like you said, Levin, we just don't know right now, right? Richard also has another comment here. Was it in a supernova that shoots out mass? I'm an amateur. Yeah, supernovas do, but
yes,
I think maybe the important thing to clarify is, do they create mass?
No.
Right, and I don't think that's the case.
Well, supernova is an explosion. That explosion releases the core of the star. During the explosion, releases a shock wave. Shock wave pushes a lot of matter, or just the gas that forms the star, into space. So after the supernova explosion, there is a lot of matter spilled in space, right? So if we are interested in the remnants, or what remains behind after supernova explosion, it may be a neutron star or a black hole or a pulsar, depending on the initial mass. But the matter spread in space just goes and spreads around, and finally they meet with young nebulae. So one profound question, like where is the heavier elements? Like our sun is not old enough to make iron, right?
Yep. Yeah.
So, but we have iron on Earth. So where did it come from? It didn't come from our sun, or it didn't come from the initial the nebula that formed the entire solar system. So where did that iron come from?
From an exploding star.
An exploding star spilled all the made iron into the universe, and that material mixed in with the new nebula, new gas clouds, and when they form stars and planet systems, that's where the heavier element got them from. So our sun is not old enough to make heavy elements because it is still burning hydrogen. It is continuously making helium for us. Not for us, but it is just for its own energy sake. it is making helium.
All right, so that does it for the show today. But we had two big things that came out of this. Apparently, we have to do a show on
Aliens.
ETs, aliens, and then we also need to talk about warp drives. So we got to get Dr. Musalek in here,
Or Dr. Lopez.
or Dr. Lopez. Yeah, it could be either one. But anyway, yeah, it was a good stream. Thank you guys for coming.
All right, I enjoyed too. So see you next week with
Yeah.
more space news and updates.
Yeah, bye bye everybody.